A winter service vehicle, or snow removal vehicle, is used to clear thoroughfares of ice and snow. Many authorities also use smaller vehicles on sidewalks, footpaths, and cycleways. Road maintenance agencies and contractors in temperate or polar areas often own several winter service vehicles, using them to keep the roads clear of snow and ice and safe for driving during winter. Airports use winter service vehicles to keep both aircraft surfaces and runways and taxiways free of snow and ice, which, besides endangering aircraft takeoff and landing, can interfere with the aerodynamics of the craft. The earliest winter service vehicles were snow rollers, designed to maintain a smooth, even road surface for sleds. Although horse-drawn snowplows and gritting vehicles are recorded in use as early as 1862, the increase in motorcar traffic and aviation in the early 20th century led to the development and popularization of large motorized winter service vehicles. History. Although snow removal dates back to at least the Middle Ages, early attempts merely involved using a shovel or broom to remove snow from walkways and roads. Before motorized transport, snow removal was seen as less of a concern. Unpaved roads in rural areas were dangerous and bumpy, and snow and ice made the surface far smoother. Most farmers could simply replace their wagons with sleds, allowing the transport of heavy materials such as timber with relative ease. Early communities in the northern regions of the United States and Canada even used animal-drawn snow rollers, the earliest winter service vehicles, to compress the snow-covering roads. The compression increased the life of the snow and eased passage for sleds. Some communities even employed snow wardens to spread or pave snow onto exposed areas such as bridges, to allow sleds to use these routes. However, with the increase in paved roads and the increasing size of cities, snow paving fell out of favor, as the resultant slippery surfaces posed a danger to pedestrians and traffic. The earliest patents for snowplows date back to 1840, but there are no records of their actual use until 1862, when the city of Milwaukee began operating horse-drawn carts fitted with snowplows. The horse-drawn snowplow quickly spread to other cities, especially those in areas prone to heavy snowfall. The first motorized snowplows were developed in 1913, based on truck and tractor bodies. These machines allowed the mechanization of the snow-clearing process, reducing the labor required for snow removal and increasing the speed and efficiency of the process. The expansion of the aviation industry also acted as a catalyst for the development of winter service vehicles during the early 20th century. Even a light dusting of snow or ice could cause an aeroplane to crash, so airports erected snow fences around airfields to prevent snow drifts, and began to maintain fleets of vehicles to clear runways in heavy weather. With the popularization of the motor car, it was found that plowing alone was insufficient for removing all snow and ice from the roadway, leading to the development of gritting vehicles, which used sodium chloride to accelerate the melting of the snow. Early attempts at gritting were resisted, as the salt used encouraged rusting, causing damage to the metal structures of bridges and the shoes of pedestrians. However, as the number of motoring accidents increased, the protests subsided, and by the end of the 1920s, many cities in the United States used salt and sand to clear the roads and increase road safety. As environmental awareness increased through the 1960s and 1970s, gritting once again came under criticism due to its environmental impact, leading to the development of alternative de-icing chemicals and more efficient spreading systems. Design. Winter service vehicles are usually based on a dump truck chassis, which are then converted into winter service vehicles either by the manufacturer or an aftermarket third party. A typical modification involves the replacement of steel components of the vehicle with corrosion-resistant aluminum or fiberglass, waterproofing any exposed electronic components, replacement of the stock hopper with a specially designed gritting body. The addition of a plow frame, reinforcement of the wheels, bumpers to support the heavy blade, and the addition of extra headlamps, a light bar, and retroreflectors for visibility. Other common changes include the replacement of the factory stock tires with rain tires or mud and snow tires, and the shortening of the vehicle's wheelbase to improve maneuverability. For smaller applications, smaller trucks are used. In Canada, pickup trucks are used with snow removal operations with a blade mounted in front and optional de-icing equipment installed in the rear. Underbody scrapers are also used by some agencies and are mounted between axles, distributing plowing stresses on the chassis more evenly. In most countries, winter service vehicles usually have amber light bars, which are activated to indicate that the vehicle is operating below the local speed limit or otherwise poses a danger to other traffic, either by straddling lanes or by spreading grit or dericer. In some areas, such as the Canadian province of Ontario, winter service vehicles use the blue flashing lights associated with emergency service vehicles, rather than the amber or orange used elsewhere. Many agencies also paint their vehicles in high-contrast orange or yellow to allow the vehicles to be seen more clearly in whiteout conditions. Some winter service vehicles, especially those designed for use on footpaths or pedestrian zones, are built on a far smaller chassis using small tractors or custom-made vehicles. These vehicles are often multi-purpose, and can be fitted with other equipment such as brushes, lawnmowers or cranes, as these operations are generally unable to run during heavy snowfalls. There is generally little overlap between the different uses, reducing the size of the fleet required by the agency or contractor. Modern winter service vehicles will usually also have a satellite navigation system connected to a weather forecast feed, allowing the driver to choose the best areas to treat and to avoid areas in which rain is likely, which can wash away the grit used. The most advanced can even adapt to changing conditions, ensuring optimal gritter and plow settings. Most run on wheels, often with snow chains or studded tires, but some are mounted on caterpillar tracks, with the tracks themselves adapted to throw the snow towards the side of the road. Off-road winter service vehicles mounted on caterpillar tracks are known as snowcats. Snowcats are commonly fitted with snow plows or snow groomers, and are used by ski resorts to smooth and maintain pistis and snowmobile runs, although they can also be used as a replacement for chairlifts. Military winter service vehicles are heavily armored to allow for their use in combat zones, especially in Arctic and mountain warfare, and often based on combat bulldozers or Humvees. Military winter service vehicles have been used by the United Nations, Kosovo Force, and the U.S. Army in Central Europe during the Kosovo War, while during the Cold War, the Royal Marines and Royal Corps of Signals deployed a number of tracked vehicles in Norway to patrol the NATO border with the Soviet Union. Operation. Winter service vehicles are operated by both government agencies and by private subcontractors. Public works in areas which regularly receive snowfall usually maintain a fleet of their own vehicles or pay retainers to contractors for priority access to vehicles in winter, while cities where snow is a less regular occurrence may simply hire the vehicles as needed. Winter service vehicles in the United Kingdom are the only road-going vehicles entitled to use red diesel. Though the vehicles still use public highways, they are used to keep the road network operational, and forcing them to pay extra tax to do so would discourage private contractors from assisting with snow removal on public roads. Winter service vehicle drivers in the United States must hold a Class A or Class B commercial driver's license. Although some agencies in some areas, such as the U.S. state of Minnesota, allow winter service vehicle drivers to operate without any extra training, most provide supplemental lessons to drivers to teach them the most effective and safe methods of snow removal. Many require that trainee drivers ride along with more experienced drivers, and some even operate specially designed driving simulators, which can safely replicate dangerous winter driving conditions. Other organizations require that all staff have a recognized additional license or certificate. The United Kingdom Highways Agency, for example, requires that all staff have both a City and Guilds qualification and a supplemental winter maintenance license. Winter service vehicle drivers usually work part-time, before and during inclement weather only, with drivers working a 12 to 16-hour shift. Main roads are typically gritted in advance, to reduce the disruption to the network. Salt barns are provided at regular intervals for drivers to collect more grit, and bedding is provided at road maintenance depots for drivers to use between shifts in heavy or prolonged storms. Weather conditions typically vary greatly depending on altitude. Hot countries can experience heavy snowfall in mountainous regions yet receive very little in low-lying areas, increasing the accident rate among drivers inexperienced in winter driving. In addition, road surface temperatures can fall rapidly at higher altitudes, precipitating rapid frost formation. As a result, gritting and plowing runs are often prioritized in favor of clearing these mountain roads, especially at the start and end of the snow season. The hazardous roads through mountain passes pose additional problems for the large winter service vehicles. The heavy metal frame and bulky grit makes hill climbing demanding for the vehicle, so vehicles have extremely high torque transmission systems to provide enough power to make the climb. Furthermore, because the tight hairpin turns found on mountain slopes are difficult for long vehicles to navigate, winter service vehicles for use in mountainous areas are shortened, usually from 6 wheels to 4.